Hey guys, it's Mr. C, and in this video we're going to be talking about some radical expressions and simplifying radical expressions. And so this is going to be kind of a lengthy video. There's a lot of examples, so feel free to come back to it and kind of do it in parts because I'm really not sure how long this one's going to last. So let's get to it. We need to simplify the square root of 48. We're going to start out really simple, and we're just going to simplify some square roots here. So when you simplify a square root, we all know that for a square root, the 48 is called the radicand. That's the item underneath the radical here. And if you don't see a little number here, which we call the index, we assume that that's a 2 for a square root. So just to kind of let you know that. What you have to do here is you have to take these numbers, you have to break them down into their primes, and then you have to see what kind of primes kind of fall out in pairs. So we're going to talk about that. So let's take 48 and break it down. So 48, and probably the easiest thing to do is if you know that a number is even, just divide it by 2. So if we divide that by 2, and 2 is prime, so I circle it. I always circle my primes. 2 times 24 is 48. 24 is also even, so times 2 again, that's 12. 12 is even, times 2 again. And that is going to be 6 over there, and 6 breaks down into 2 and 3. Any two numbers will work. It doesn't matter which ones you choose, as long as both of those numbers multiply to give the previous one. So one thing I'll mention here is called the fundamental theorem of arithmetic, and that says that no matter how we break these numbers down, all of these primes, we are all going to get the same primes, just in maybe some other order or configuration down here. But there's only one way to make 48, and that's 2 times 2 times 2 times 2 times 3, and then that's it. So what we want to do then is we want to take pairs of primes down here, and we're going to pull them out as 1 on the outside. So a pair of factors is equal to 1 on the outside. So what I do is I cross through these two, and I'm going to put a 2 right here. We'll cross through these two, that pair, and we'll multiply that by another one. Now anything that's left is going to stay underneath the square root, the radical, because it didn't have a pair. So I'm going to put a square root of 3 right there. All right, so then anything that's out here that needs to be multiplied, you have to do that. So 2 times 2 is 4, and then 4 root 3 would be your final answer for that one. So how do you know that that is correct? Well, one way to do it on a calculator, which you don't want to do because your test probably won't be multiple choice, is you can say 48 and then hit the square root key and get a decimal. And it's about 6.92820,323. It's irrational, so it's going to keep going. Also, you can take this number that you previously got, 3 square root, and then times 4 equals, and you get the same exact decimal. And so now I know for sure that this number and this number are equivalent, but this is the one that's been simplified. So I'm not going to do that every time on the calculator, but I just wanted to show you that in case you do have a calculator handy, you can check your work. So 4 root 3 was the answer for that one. Okay, next one, we got root 72. So again, we're going to break that down. 2 times 36. 36 is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. All right, so again, in pairs, I see a pair of 2s. I see a pair of 3s. And then that 2 right there is still left, so it stays underneath the square root. 2 times 3 is 6. And 6 root 2 would be our final answer for that one. Root 135, let's try that one. So 135, you have to know some basic divisibility rules for some smaller numbers. Because it ends in a 5, we can go ahead and divide by 5. We know that 5 goes into it. So we're going to go ahead and start with 5. Okay, another number I know that goes into it, 5 plus 3 plus 1 is 9. That means 3 goes into it because 9 is a multiple of 3. And not only that, but since that's a multiple of 9, 9 goes into it too. So 5 wasn't my only option at the beginning. So 5 times 27. 27 is going to break down as 3 times 9. And 9 breaks down into 3 times 3. All right, so I've got a pair of 3s. So 3 comes out. I could have chosen that one, but I chose these two. Now these two numbers are still left underneath. When you have more than one number left underneath, just multiply them together, which would be 15, and put that under the radical. And 3 root 15 is going to be my final answer for that one. 192. So as the numbers get bigger, generally they're going to have more factors. And so if we take 192, and we might as well, since it's even, start with 2. And that's going to be 96. Okay, so we're going to go ahead and break that down. And 96 divided by 2 is 48. Now we're kind of like right back to where we were with the 48, aren't we? And so if we already know what 48 breaks down into, 4 2s and a 3, we could use that. Or we could keep going again. Let's say we didn't know any better. 2 times 24. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. A lengthy one here. All right, so let's take some pairs here. I got a pair of 2s, so 2 comes out. Another pair of 2s, another 2 comes out. A third pair of 2s, another 2 comes out, and I have a 3 still left underneath. So that 3 stays. 2 times 2 times 2 is 8. Don't mistake that for 6. Do that all the time. So 8 root 3 is going to be my final answer for that one. Next we have 520. And so 520, I would just go ahead and say maybe 52 times 10. Both of those are composites, so I'm not going to circle them. 10 is 2 times 5, and that's done. So now we have 52. 52 is 2 times, and if you take 52 and divide it by 2, you get 26. And 26 is 2 times 13. All right, so again, we have different orders here than previous because I just divided by 2 each time previously. This time I did it a little bit differently. I started with 52 and 10. The process is still the same. I got a pair of 2s, so that 2 comes out. I got a 13, a 2, and a 5. Now that 13, 2, and 5, they're all different. So 13 times 10 would be 130. All of that's going to go back underneath the square root. And there's really nothing else you can do with that one. It's pretty much done. All right, so here we have root 576, or 756, excuse me. So this time, we're going to take it and let's just go ahead and start with 2 just for fun. So we got 756 divided by 2, which is 378. Okay, we're going to do that again. By 2, and we get 189. Okay, so 189, that's a pretty big number. What goes into 189? 9 plus 8 is 17, and another 1 is 18, which means 9 goes into it. So we're going to divide that by 9, and we're going to get 21. Pretty handy rule. 9 is going to be 3 times 3. 21 is 7 times 3. All right, so let's see what we got. We've got a pair of 2s. We've got a pair of 3s. The 7 and 3 have no pairs, so they're just going to go back in as a 21. 2 times 3 is 6. And so 6 root 21 is going to be our final answer for that one. All right, so now we have 54x squared. Now we have some variables underneath, and we're going to see what to do with those. So the first thing you want to do when you have variables and numbers is break the number down. So we're going to break our number down here. 54, let's go by 2 again. So 54 divided by 2 would be 27. 27 is 3 times 9, and 9 is 3 times 3. You want to get good at making your factor trees, try and do them fairly quickly. All right, so let's see how this is going to break down. We got 2 3s, so that pair of 3s is coming out, definitely. This 3 and that 2 are going to stay. And now let's look at the x. The x squared, I have 2 x's underneath, and I have an index of 2. which means when these both numbers match, a single one comes out. So how many pairs of 2 go into 2? Well, just 1. And so that single x is going to come out. And the reason why was because they're actually equal to 2 x's underneath the square root. So let me do a little side calculation here just to show you what's happening. So I've got root 54x squared. So really what that was 2333, 2 times 3 times 3 times 3 times 2 x's. Now nobody's going to want to write all this stuff out like this, but it's going to be visual for me to show you this time. So what happens is you see I cancel them in pairs over here. They also come out as pairs. It's the same thing. So these 2 3's right here came out as a single 3 on the outside. These 2 x's are going to come out as a single x on the outside right there. That 2 and that 3, like I just said, are going to stay underneath, and it's going to be a square root of 6 right here. Now, in a lot of textbooks, they may put absolute value bars around that x right there to make sure that you only get the positive value. I'm not going to worry about that in this course. I would worry about that in maybe other courses, but this one, I'm not too worried about putting absolute value around the variable and going into that detail. So for now, let's just be comfortable with taking some things out of here when they simplify, and then we'll be okay. 3x root 6 is our final answer for that one. Okay, 243x cubed. So we got to break down 243. And so you take 243 and you start to try and figure out, well, what goes into 243? Well, let's add them all up. 4, 5, 6, 7, 8, 9. If you add up all the digits, it's a multiple of 9, the sum of all the digits. So I'm thinking that we could probably divide it by 9. So if we take 243 and divide it by 9, we're going to get 27. Okay, 9 breaks down into 3 times 3. Now I'm going to show you a cool thing. 27 is called a perfect cube. That means 27 is a single number times itself 3 times, and that single number is 3. So you can save yourself a little bit of time here, and if you know that this number is a perfect cube, you can put 3 little arrows off there, or little, we call it branches, and these would be leaves maybe. We know that that's going to be 3 3's that are going to make that 27. And you can do this with any perfect cube like 64 or 27 or 8 or something like that. So we got a bunch of 3's here. So let's take a look and see what's going on. So we got these 2 3's are going to come out. These 2 3's are going to come out. And then that's it. That 3 stays. What about these 3 x's? Well, let's look at the index. The index is 2. I can take a pair out of here as a single one on the outside, but there's going to be 1 still left because I have to have them all add up to 3. So that 1 still left is still going to be under there. And so when I write my square root, I have to write it as 3 and then that extra x that didn't come out. 3 times 3 is 9. So I have 9x times root 3x for my final answer for that one. Okay, this one, got 81. And so 81 is 9 times 9. And both of these are going to be 3 and 3 and 3 and 3. Okay, so I got the number broken down. I got a pair of 3's. I got another pair of 3's. Okay, let's look at the x's. I have an index of 2. So how many groups of 2 can I take out of 4? Well, that would be 2 groups. Or you could do this. 4 divided by 2 is 2. So I can take a pair of x's out for an x squared. 6 divided by 2 is 3. I can take 3 groups out of the y's. And now what's left underneath? Nothing here, nothing here. Everything got taken out. So there's nothing left under the square root. So now I'm going to go over here. 3 times 3 is 9. 9x squared y cubed would be my final answer for that one. All right, let's take a look at this one. Okay, this one, I got 120. So we'll break that down into 12 and 10. 10 is 2 times 5. You'll get better at this too, because you'll start to see the same numbers over and over. 12 is 6 times 2, and 6 is 2 times 3. Okay, now I need to take a pair of 2's out. Okay, 3, 2, 5 are all singles. They don't have a pair, so they're going to stay. So that's going to be 5 times 2 times 3, which is 30. So all that's staying. I can take a single x out, because how many groups of 2 can I take out of 3? 1. How many groups of 2 can I take out of 4? 2. And then still times the square root of 30. So, and I have an extra x here, so I can't forget that. So that extra x has to stay under there too. All the y's came out, but that extra x to make up 3 is still left underneath there right here. So my final answer would be 2x y squared times the square root of 30x. So we're getting a little more complicated here, and so I'm gonna have to start writing my answers somewhere else, but that's my final answer for that one. Again, you can look at these videos anytime you want. You can rewind them, go back, take a look at it again, ask questions. All right, 156. The hardest thing about these is breaking down the number. Let's go with 2. So 156 divided by 2 would be 78. All right, let's go with 2 again. So we divide that by 2 and we get 39. I could keep going. 39 is going to be 13 times 3. But both those numbers aren't going to have a pair anyway. So now I have a pair of 2's. Okay, now the 13 and 3 are going to stay. Let's move on to the variables. Still got a 2 there. How many pairs of 2's can I take out of 4? That would be 2. So x squared. How many pairs of 2's can I take out of 3? Just 1. But I'm going to have an extra y still left under there, so I got to be careful with that. So times the square root of 13 times 3 is 39. And then that extra y right here. And so my final answer, 2x squared y times the square root of 39y. And there it is. Let's change markers because these are going to start drying out here really quick. Got a lot of examples to do. Okay, so we got 216, and now we have a cube root. So now I want 3 of an item to come out as 1 on the outside. So I'm looking for 3. So let's break down 216. 216, we can go by 2. So 216 divided by 2 is 108. 108 is 2 times divided by 2, and we get 54. 54 is 2 times 27. And look, now we can apply our little trick here. 3 on there because it's a perfect cube. 3 3's. All right, so now I'm gonna probably run out of room over here, so I'm gonna have to work over here on this side. So now I want 3. I gotta remember, this index tells me how many I can take out as a group to make 1 on the outside. So I have 3 3's, so I've got a 3 coming out. I've got 3 2's, so I've got a 2 coming out. Now that's everything down here, so there's no more number under there. How many groups of 3 can I take out of 6? Well, 6 divided by 3 is 2 groups. So times x squared. And how many groups of 3 can I take out of 9? 3. Y cubed. So my final answer would be 6x squared y cubed. And remember, when everything comes out of the square root, and I mean everything, like this one, everything simplified, there's still a 1 left under here. So it doesn't go to 0, it just goes to 1. And when you have the square root of 1, if you guys remember, square root of 1 is equal to 1 anyway, it just goes away and we don't even write it over here in our final answer. All right, now let's move on to adding some radicals and see how that works. And we're going to mainly talk about square roots, because in Algebra 1, that's really what we do. 4 root 3 plus 6 root 3. All right, so one thing we can't do is we can't add these together and then add these together. That doesn't work that way. So there's no rule for that anyway. So what we do is we look at these radicals, and then we look at these 6 and the 4 here. We think of those as coefficients. So we think of these as variables, even though they're not. We think of these as coefficients. So they both have a root 3 on there. So I always say this to my class: what's 4 apples plus 6 apples? And everybody says 10 apples. Well, the apples is the root 3 part. And so 4 of them and another 6 of them would logically make 10 of them. And so 10 root 3 would be your final answer. You can't simplify that any further, and then that's it. Here we have another one. 5 root 2's, take away 3 of them, would leave you with 2 of them. And then that's it. So they're very simple whenever you have the same radical with each of these terms right here. This one we do not. And we also have to simplify each time too. The square root of 8. The square root of 8 and square root of 2 are two different radicals. And so what we need to do is we need to take this guy right here and simplify that if we can. So let's go over here and let's see what the square root of 8 is. The square root of 8, if we break it down, would be 2 and 4. And 4 is 2 and 2. So if we break the square root of 8 down, we're going to see this quite a few times. So we're going to use this knowledge after we get done here. There's a pair, and then there's an extra. So the square root of 8 is the same thing as 2 root 2. And so if I go to my calculator and I take 8 square root, it's 2.828427125. It's irrational. If I go 2 square root times 2, I get the same exact number. So we know now that these two guys right here are equivalent. But this one's been simplified, and that's the one I want. So I have 3 of these root 8's. So I'm going to replace the root 8 with the 2 root 2 that it equals. Still plus the 2 root 2 over here. Now, when I take this number out front, I need to multiply that by the 2 that's here from my simplifying part. The 3 was already there. The 2 now gets introduced because of this equal to that root 8 right there. So that root 8 is actually equal to 2 root 2. So what we do is we take the 3 and the 2 here and we multiply them. Do not do anything with the square root of 2. Leave that. 3 times 2 is 6 root 2 plus 2 root 2, and now we're back to one of the previous ones we had. 6 of them plus 2 more will make 8. And then that's your final answer for that one. Okay, here we have 2 root 8's, but as we've already seen, the square root of 8 is equal to 2 root 2. The more times you see this, the more it's going to stick in your brain. So we have to replace both of these root 8's with the 2 root 2 in parentheses. So I have 5, 2 root 2, plus 7, 2 root 2. So 5 times 2 is 10. So 10 root 2's plus 7 times 2 is 14. 14 root 2's. That's going to give me a grand total of 10 and 14 make 24 root 2. And if you had a calculator where you could put all this in there, all of this right here would be equivalent as a decimal to this. So 24 root 2 is going to be our final answer for that one. All right, 6 root 27 minus 2 root 3. It'd be nice if root 27 was something with a root 3 on it. Let's see if it is. Root 27, let's break it down. 27, if you remember, is 3 times 3 times 3. A pair of 3's well, they don't cancel. They come out as 1 on the outside. And that 3 right there is still on the inside. So now anytime we see a root 27, we can replace it with the 3 root 3. And that's going to be very handy because that's exactly the same radical we have here. So we have 6 times 3 root 3 minus 2 root 3. 6 times 3 is 18. Minus 2 root 3. 18 take away 2 is 16. So 16 root 3 should be our final answer for that one. Okay, we have a similar one here. Again, we're going to take that root 27 and replace it with 3 root 3 because we know already that that's what's going to be. There's no use doing that every time. We know it's going to be 3 root 3. So we have 3 times 3 root 3 plus another 3 root 3. 3 times 3 is 9. So we have 9 root 3 plus another 3 root 3. 9 and 3 make 12. So this whole thing is 12 root 3. All right, let's try this one. Now we have root 20 plus root 45. And you definitely cannot add the 20 and the 45. Please do not ever do that. It's not going to work unless it's a very, very, very special case. And it will not work in general because there is no rule that says this right here. Root A plus root B is equal to the square root of A plus B. And students will do that all the time. That is a no-no. We're going to cross through that because that does not work. What we need to do is break these numbers down. 20 is 10 and 2, and 10 is 5 and 2. Which means the square root of 20 is really 2 root 5. Let's do the same thing with 45. Let's use a different marker here. We know that 45 is 9 times 5. 5 is prime, so I circle it. 9 is 3 times 3. I've got a pair of 3's and a single 5, so that's going to be 3 root 5. So once I simplify both those, I see that I have a root 5 on both of them, which is nice because now I can add them together. If these were different numbers, then I could not add them together right away. I maybe could do something else, or possibly I couldn't do anything if these were different. 2 root 5s and another 3 make 5 root 5. And that's your final answer. Same thing here. The 2 root 3 is already broken down, but the 12 is not. So 12 is 2 times 6, and 6 is 2 times 3. So root 12 is 2 root 3, plus another 2 root 3. That's interesting. 2 root 3's and another 2 root 3's make 4 root 3. And that's it. 6 root 18 minus 2 root 8. So we got to break these down. Well, we already know this guy. We already know that's going to be 2 root 2. Oop, my light shut off. Give me a second. That's what happens when I have a classroom with lights. There we go. Always fun when that happens. All right, so we already know that root 8 is 2 root 2. Okay, but we don't know what root 18 is, so we have to break that down. That's going to be 2 times 9, and 9 is 3 times 3. So root 18 is actually going to be 3 root 2. But there's still a 6 here, so we got to multiply that by the 6 that's already there, minus 2 times, and now we got to replace that root 8 with 2 root 2 in parentheses. Okay, so we got 6 times 3 is 18 root 2's, minus 2 times 2 is 4 root 2's. 18 take away 4 is 14. And so our final answer would be 14 root 2. Okay, we got 3 root 6 plus 4 root 24. Root 6 isn't going to simplify at all. 6 is 2 times 3. So we might as well just leave that. That's not going to help us out at all. But 24 may. Let's see what that's going to be. 24 is 2 times 12. 12 is 2 times 6. I'm going to stop there for a second. I see that 6 and I see that 6. What's going to happen is these two 2's are going to come out. So this 3 root 6 is going to stay over here. But I got 4 times that 2 is going to come out as a single one on the outside, and that root 6 is going to be left underneath. That's what's going to happen. So I've got 3 root 6 plus 4 times 2 is 8 root 6. And now I have a grand total of 8 plus 3 is 11. Root 6 for that one. It's a good problem. And you can stop here at any time when you're factoring these numbers if you find something that's going to be advantageous to you. Although you could have kept going and said 2 times 3, but your very next step you would have had to multiply them together anyway because they don't have pairs. All right, root 63, root 28, we got 2's in front of them, so we got to break those down. Root 63 is 9 times 7. 7's prime. 9 is 3 times 3. Okay, so I got 2 times parentheses 3 root 7 minus 2 times parentheses, and here we go. 28 is 7 times 4, and 4 is 2 times 2. So we all kind of see by now what's going to happen. 2 comes out, root 7 stays. And it's nice because I got root 7s now. 2 times 3 is 6, root 7, minus 2 times 2 is 4, root 7. 6 take away 4 is 2, and 2 root 7 is going to be my final answer for that one. Okay, now we got 80 and 45, so let's see how that works. 80 is going to be, let's just say 10 times 8. 8's interesting because 8 has 3 2's to it. It's a perfect cube. So I'm going to write all 3 2's right here because I know that's going to happen. 10 is 5 times 2. So now I have 2 times, okay, this pair of 2's is going to come out, and this pair of 2's is going to come out, and 2 times 2 is 4. So I'm going to go ahead and write the 4 there with the root 5 because the 5 didn't have a pair. Minus 3 times, and now here we go with root 45. 45 is 9 times 5. 9 is 3 times 3. So a 3 comes out. Root 5 stays. So here we have now 8 root 5 minus 3 times 3 is 9 root 5. 8 take away 9 is actually -1, so -1 root 5 for our final answer. So yes, you can get negative answers with these. It just depends on the structure of the original expression. Okay, so we did adding, subtracting. Let's do some multiplying. So if you multiply 2 radicals together, you do have a rule that says this: root A times root B is equal to the square root of A times B. So that rule does hold. The addition one does not. So 8 times 2, what you're going to do is multiply these guys together. 8 times 2 is 16. So really this is going to be the square root of 16. Now, nicely, the square root of 16 is 4. So if you multiply these 2 expressions together, you're going to get the square root of 4, no problem. That's what it's going to be. And that's it. That happens sometimes, and then sometimes you don't get a nice number when you get done. By nice number, I mean integer. All right, so let's do 54 and 6. So 54 times 6, let's see, 54 times 6 is going to be 324. And now the numbers got kind of big, so let's take the square root of that. And if you actually take the square root of that, you get 18 exactly. And 18 is our final answer. 12 and 3, 12 times 3 is 36. And we know that the square root of 36 is 6. And that one is done. Okay, now we have the 216 times 6. So if we multiply 216 times 6, we get 1296. And the square root of 1276 is going to be 36. Now, what if I didn't know that? If I didn't know that it's going to be 36, then I have to take 1296 and break it completely down, and then I would have to see how many pairs I have for everything, and then take the pairs out. But if I did that, all those pairs would multiply together to give 36 when I took them out. All right, so now we've got some other expressions. If you get some parentheses here with some square roots in it and a square root on the outside, you're still going to distribute. So let me change markers here. You're still going to distribute. When you distribute, you're multiplying. And when you multiply, again, you multiply these two guys together. So root 2 times root 5 is actually the square root of 10. Still plus. And now we have the square root of 2 times square root of 7. 7 times 2 is 14. Okay, so how can you mess that up? Easily, adding those two numbers together. So you don't want to add those together, you want to multiply them and then see what happens. Now, 10 and 14 couldn't be simplified. If they can be simplified, then you have to, by doing your little factor tree, or if you already know what it is. But 10 and 14 were not simplified. You can't take these and add them together. If you try and add these together and make the square root of 24, you're done for, because again, that rule does not hold at all. So that you do not want to do. Make a note of it. That's your final answer with two terms in it. Okay, so we have a variety of these happening here. Root 3 times root 3. The square root of 3 times another square root of 3 is going to be just plain old 3. Now, why is that? The square root of a times the square root of a. If we multiply these together, a times a, we get a squared. But as we know, a square and a square root cancel each other out. And the reason why they do is because they are inverses of each other. So a square and a square root cancel each other out, and you just get that same number back that you originally had underneath each of these. So root 3 times root 3 is 3. Root 3 times 4 is going to be plus 4 root 3. You couldn't multiply these together because this one doesn't have a square root on it. You just have to put the 4 in front of the root 3 as a multiplier. 4 times root 3, done. And there's nothing else you can do with that. All right, let's try this one. Root 6 times 2 is going to be 2 root 6. Okay, minus root 6 times root 6, as we just saw in the last one, is going to be just 6. Now, this answer is fine. I'll accept that. But usually in the back of a textbook or a professor, you usually write a radical last. And so they would probably rearrange this into negative 6 plus 2 root 6. And there's reasons for that you learn later in math. But either one of those answers for me would be acceptable. That'd be fine. Okay, this one, root 8 times root 2, that would be root 16. And root 16 is 4 plus root 8 times root 8 is 8. You just get that same number back. 8 plus 4 is 12. And it turns out that that's what you get, 12. Okay, let's do some division. With division, we do have a rule that says root a over root b is equal to the square root of the whole thing, a over b is a fraction. And when you have these identities like this, you can go backwards or forwards with that. You could take the fraction and the square root and break it up into 2 if it helps you, or you can combine them as 1 on the inside. So this time, I'm going to combine them as 1 on the inside. So if I combine them as 1 on the inside, I would actually get the square root of 6 divided by 2. So how does that help me out? 6 divided by 2 is 3. And I wind up with root 3. But root 3 is, you can't simplify that, so it's done. So there's another way you could do this. You could have written the root 6 as root 2 times root 3. Because remember, we can break that number up into its individual factors, each with a square root over root 2. These are the same thing over itself, so they cancel because they're multiplicative inverses, and you wind up still getting root 3. So either one of these methods works. You get root 3 every time. Okay, here we have root 30 over root 5. So this time, let's go ahead and let's put them under a big radical like this. 30 divided by 5. 30 divided by 5 is 6. And so all this is going to shake down to square root of 6. And then that's it, because root 6 you can't simplify at all. Root 50 over 8. Let's see how this is going to work if I try it this way. 50 divided by 8. So I can take both those numbers and I can divide them by 2. in the fraction to simplify my fraction. So this would really be root 25 over 4. So that's pretty interesting because now I can take this and I can break it up into two separate square roots over each other. Now, how does that help me out? Because root 25 is 5 and root 4 is 2. And so my final answer would be 5 halves. And that's it. Okay, so here we have root 2 over 2, and we need to simplify. So what this is going to be called, and this is only one example, but we're going to rationalize the denominator. So when you rationalize, you're trying to get rid of the radical in either the numerator or denominator. In this case, we want to get rid of the denominator. And the reason why is because mathematicians consider this to be unsimplified when you leave it down there like that, for reasons that you're not going to understand for a while. But what you do is you basically multiply it by the same exact square root here and here, because all of this is equal to what? It's equal to 1 because it's the same number over itself. But look what it does for me. I get 2 root 2 in the numerator, but the denominator, root 2 times another root 2, as we saw, is just 2. Now, these 2's will cancel. This one always stays. You don't ever mess around with this. And root 2 is my final answer. So if you put this expression in the calculator and this one, it would give you the same exact decimal. Okay, so now we're going to talk about converting back and forth between rational exponents and radicals. So here's how this works. A to the 4/5. So the 5 is going to go as the index on the outside, and the 4 is going to be an exponent with the variable or number or whatever this is. And so when you're converting an expression like this to a radical, this number goes on the outside, that's your index. This one is going to be your exponent on whatever this is. So the 5th root of a to the 4th, and you are done. Okay, this one, same thing. The 8 is going to go as the index. And we're going to have x cubed on the inside. So what do students usually do to mess this up is they'll take the 3 and the 8 and they'll switch them. They do that all the time, no matter how many times you say it, or practice problems, they'll still do it because they can't remember which one goes where. But it's a very simple thing. This one is going to go to the outside. This one is going to stay with the variable. Okay, this one, 10 over 12, I'm actually going to do something first here. I'm going to take that 10 over 12 and simplify it. That would simplify into 5 over 6. And so now I'm going to put the 6 on the outside. I'm going to put the n on the inside with the 5, the 5th power, and I'm done with that one. Okay, so now we're going to get into some final exam EOC type questions. You have an A and a B. They both have the same denominator, which is nice, but they have different exponents, different numerators. So this denominator, both of these, is going to come out as the index since they're the same. I'm going to put a little 2 there. I know I don't need it, but I'm going to put it there anyway. So I have a to the 1st power, which is just a, b cubed, and that is how you write your final answer when you convert that one to a radical. This one does not have the same denominator. Since this one does not have the same denominator, I have to get the same denominator. So before I even start playing around with this, I need to get a 12 here and a 12 here because that's my least common denominator. So let me do this. I'm going to write x, and I'm going to write y over here. Okay, I want 12s. So I have to rename these fractions. 4 times 3 is 12. 3 times 3 is 9. 9 goes there. 4 times 3 is 12. 4 times 2 is 8. And 8 over 12 is the same thing as 2/3. Now I have the same denominator. That's going to be my index. I'm going to have x to the 9th, y to the 8th. X to the 9th, y to the 8th. So it looks really complicated, but after you get that common denominator, it's really not. And this is one that they usually ask. And so I have a 6, a 3, and a 2. So 6 is going to be my common denominator. So x, y, and z. So I want a 6 here, a 6 here, and a 6 here. Well, I already have the 1/6 for the x. 3 times 2 is 6. 2 times 2 is 4. So 4/6 and 2/3 are the same. I want a 6 down here. 2 times 3 is 6. 3 times 1 is 3. And 3/6 is the same thing as 1/2. So now I can go ahead and write my radical as a 6 on the index, x to the first power, y to the fourth power, z to the third power. And I'm done with that. Okay, so now we have some radical expressions we need to write as a rational exponent. So remember, if this is a square root, the index is 2. So we have the square root of x cubed. So what would that be? So the x is going to be our variable, that's our base. The 3 is going to be the numerator. The 2 is the denominator. And we're done. That's it. Same thing here. Here's our x. The 2 is our numerator. 4 is our denominator. Now this one, can we do anything with that? We can simplify the 2/4 into 1/2, and that just looks a little bit better if we do that. Okay, this one, the a is our base. 4 is going to be our numerator. 3 is our denominator for our rational exponent. And that's it for that one. Okay, this one, of course, we're going to move into different numbers of variables here, but that's x to the first power. And so we're going to have x to the 1/4 times y to the 3/4. And that's it. That's all you have to do. Again, we have 2 variables. So this one is going to be a to the 7/8 times b to the 4/8. All right, so can we simplify any of these? We can take the 4/8 and reduce that down to 1/2. And so a to the 7/8 times b to the 1/2 is a better final answer for that one. And our last example is going to be x, y, and z. So x, y, and z. 2/4 for x, which is going to get simplified. 3/4 for y. 4/4 for z. And those are all multiplied together. So we can simplify the 2/4 as 1/2. 3/4 stays, because you can't simplify that. And 4/4 would be 1. And so we'll just leave it as a z right there. All right, guys, it's a long video, but lots of information. Remember to like my video and subscribe to my channel if you haven't already. And I'll see you guys later. Bye.